We have done a little bit of this already, but we're going to do some more stuff with tangent. Now, since your calculator has stored every possible ratio that exists, we can use that to help us solve for side lengths as well. We're going to use the same process to start that we did with the ones where we solved for the angles. So in solving for the angles, we want to determine the length of xy. What little letter would I put on this side? Little x, little y, little z, because it's opposite angle z. And the angle that we know is angle z is 70 degrees. So using the angle of 70 degrees, we could write out the definition of tangent. Tangent of 70 degrees is opposite the 70, which is the z that we do not know, over the adjacent, which is the 5. Okay? One thing to remember with a triangle, okay? This side opposite the 90 degrees is always your hypotenuse. I'm going to circle the 70 degrees in blue. And if you're talking about the 70 degrees in blue, then this side is your opposite side, and this side is your adjacent side. But if I was talking about this angle, this 20-degree angle here in green, if I'm talking about the 20-degree angle, then this side is the opposite, and this side is the adjacent. So which side is opposite and which side is adjacent depends which angle you're talking about. So if I'm talking and I'm making my definition for tan of 70 degrees, it will be z over 5. If I was talking about the 20-degree angle, and I know this is 20 degrees because they all have to add up to 180. If I was making my definition for the 20 degrees, then tan of 20 degrees would equal opposite is 5, adjacent is z. So if we want to figure out what z is, our job with algebra is, can I do things to this equation to get z all by itself? Right now, z is divided by 5. What's the opposite of dividing by 5? Multiplying by 5. If I multiply both sides by 5, well, these 5s simplify away. And now I get z equals 5 tan 70. So I go to my calculator, and I can write in 5 times tan of 70, just like it shows up. And since your calculator has the ratio memorized, it says that z has to be 13.73. To the nearest tenth, 13.7 centimeters. So now we can do a quick check here. We're going to do a quick check if tan of 70 degrees is truly 13.7 divided by 5. So I'm going to go back to my calculator just to see if our ratio is right. So on the right-hand side, I have 13.7. I'm going to use all the decimal places so I don't round. That 13.7, I'm going to hit divide so it automatically takes that answer and divide it by 5. 2.74 is what happens when you take 13.7 and divide it by 5. On my calculator, it has memorized what the ratio for 70 degrees should be. So I go tan of 70 on my calculator, and it says it should be 2.747. Since it works, we know that the 13.7 is the right answer. It's the only number divided by 5 that gives us the proper ratio. So let's say you had done the green first. If you had done the green first, it's a little bit harder because the z is in your denominator. And if you try to solve for z, most people are tempted, oh, I just want to divide both sides by 5. But the problem is the z isn't by itself then. It's still on the bottom of the fraction. So as a preliminary step, we have to first multiply both sides by z. To get rid of the z on the bottom. Does that make sense? And now that it's z times tan 20, if I want to get everything, okay, I'll just write it out. It's z times tan of 20 degrees equals 5. And now, if I want to get the z by itself, at least it's not in the denominator, but I'm multiplying by tan of 20. So the opposite of multiplying by tan of 20 is dividing by tan of 20. So I would have to do that on both sides. And we get z equal to 5 over tan of 20. So if I try that in my calculator, okay, you have the fraction button on your calculator, and I can write 5 divided by tan of 20, I get 13.7 again, which is good, because it should be the same answer. So it doesn't matter which angle you choose. However, can you see it was a little bit more work using the 20-degree angle compared to using the 70-degree angle? Just because with the 70-degree angle, what we didn't know was in our numerator. So it was only one step to get it by itself. In the second one, what we didn't know was in our denominator. And with this, with practicing this over time, you might recognize, oh, I have to multiply both sides by z, so that would move the z up over here on the left side. I have to divide both sides by tan of 20. That will move tan into my denominator on the other side. And some people can do that just in one step too. Determine the length of VW. So I know I showed you sine and cosine already. That'll be little x. And there's going to be a better way to do this. But right now we're going to pretend we have only heard of tangent. So the definition of tangent, if I write tan of 42 degrees, it's my opposite side, which is 7.2 centimeters, divided by my adjacent side, which I don't know, which is w. So I can use my definition of tangent to solve for w. In this case, w is in the denominator, so we have to do that preliminary step of multiplying both sides by w. And we would get w tan of 42 degrees equals 7.2. And then we could divide both sides by tan of 42. And we get 7.2 divided by tan 42. Go to our calculator. So this time I'm showing that if you didn't use your fraction button, it will also work. 7.99 to the nearest tenth would be 8.0 centimeters. That doesn't solve for x. Now to solve for x, So I would have 7.2 squared plus, and I'm not going to round this number, because whenever we're doing our calculations, we round our answers when we state them, but when we do all of our calculations, we do not round until the very end. So if I want to do 7.2 squared, 7.2 squared plus, and I want to use that number that I had from before, I can go second answer and then square it, equals 115.78. So that would be, if I show my work, that's equal to x squared. And if I want to figure out what x is, I would square root both sides. Of course, you'd have the plus or minus, but we're dealing with a length, so we're only going to have the plus. Second square root of second answer, 10.76. Which rounds up to 10.8. Okay, what did I forget? Oh, let's be really picky. I forgot units, good. What else? What else could I do to make it even better? We could do the square root and do the plus or minus. That would make it even better. Okay, anything else? What's that? A dot above the equal sign, or squiggle it up to make it approximation? Excellent. So those are some fine details to make it even better. Your job is to draw the picture on your own first. Read through the question, draw the picture, and then set up your tangent definition. With your drawing, did you draw an observation tower? Make it nice and fancy. Yeah, liking it. Nice. There's a nice, beautiful green grass because it's September and it rains every day. And there is our tower. Now, someone is putting their head right on the ground and looking up from the ground to the tower 200 meters away, so that the angle between the ground and the line of sight. Now, line of sight is if when you look at something, if you had like Superman laser vision and you drew a line with your eyes perfectly to the top of that, that would be the line of sight. And so the angle between, oh, we should really, if we're talking lasers here, sorry, we better do this. Have to hit OK somewhere. Oh, maybe I just clicked. No. Come on. Enter. There it is. Perfect. Oh, that looks there. Now we got laser beam eyes. Good. All right. And so the line of sight, the angle between the ground and the line of sight with our laser beam eyes, that's 8 degrees. That does not look like 8 degrees. There we go, 8 degrees, right? How high is the tower? So in this case, we want to know x. How tall is our tower? right? Because you want to climb to the top and you got like a rope and a grappling hook and you want to throw it up there and you want to know how long does your rope need to be in order to. We should probably put, just for, should put at least one door, a door on the tower so someone could get in there. Okay? And so we set up our tangent ratio. Our definition of tan is if I use the 8 degrees, the opposite side is x, the adjacent side is 200. I can get x by itself if I multiply both sides by 200. I will get x by itself. I can go to my calculator, 200 times tan of 8. And notice this time I didn't put the multiplication sign in between the 200 and the tan. Because you learned in algebra when you have like 3x, it's 3 times x. You don't need a sign in between. So whenever your calculator also sees things put together, it knows to multiply them. Okay? As long as they're not just numbers. Like if you want to do 2 times 3 and you write 23, your calculator will think it's 23 unless you put it in brackets. But when I write 200 and then I switch to tan, it knows we want to multiply. 28.1 Now, is this reasonable? How, or not the drawing. The drawing, you know, is awesome. But, could a tower, is 28.1 meters, would that be a little tower? Would that be decent height? Would that be so high as like it would fall over?
Medium height.
Medium height tower?
Medium to low range.
What do you think? Do you think it's taller than this school?
Yeah, it's way taller. 28 meters, that's like long.
Okay. Something to think about. And I encourage you, whenever you get a measurement, try to see if you can visualize about what that is. What is 28 meters? Okay. This roof in here is probably a little bit more than 3 meters. Okay, not quite 4 meters. So if we did 7 times this, that's pretty high. That's a pretty high tower. It might be a little scary if you were going up the rope. Awesome. The next thing we're going to do before we get to our homework is talk about our first project. You are going to make a clinometer. And your textbook has instructions to do this. So, let's see here.